Alright, this last example is going to be like number 17. This is actually a little bit more complicated than number 17, but you can use it as for example. Something I want to point out is, again, I'm looking at the degree of the numerator and the degree of the denominator. Here, the degree is 3 because I have x squared times another x. That's x cubed. And in the top, the degree is 2x squared. So I don't have to do long division. I don't have to do it. So what do I do? Well, here's the difference here. We have to build it up in a certain way, and I'm gonna show you that right now. I'm not gonna really focus on why it works, but again, like I think I said before on the other one, but I'm gonna show you how to do it. So. Again, my goal is to break up this fraction so that it's simpler fractions. And then I can integrate those fractions individually if I have like addition or subtraction of those. So what am I going to do is do it in blue, because it rhymed. And I would have 4x squared minus 21x. I mean, I'm just rewriting this. And yeah, x minus 3 quantity squared times 2x plus 3. And I'm gonna break that up, and you'd think maybe you would just go like, oh look, you can just do a over x minus 3 squared. But you can't just do that. You can't just do that. You have to build up to the x minus 3 squared. So I have to do a linear term there, and then the b over x minus 3 squared. Now, if I were to get, ignoring everything else, if I were to get a common denominator here, I would get x times, or x, I guess it would be x minus 3, right? I'd have to multiply by an x minus 3 up here. So I would get some x thing, and then this doesn't have to be multiplied by anything, so it gets just some number. So that's nice, and then I would have my other term to get up to the x squared. So, I mean, that's not really a good explanation for why it works, but we're still just going to do it. So, when you have repeating linear factors, that's what this is. This is a linear factor, and it repeats twice. When you have repeating linear factors, you have to build up to it, meaning you have to do it all by itself and then squared. If this was to the third, then you would do it all by itself, and then squared, and then x minus 3 cubed. That's a terrible cube. But you have to build up to it. That's the thing to take away from this example. And I also have plus c over the last linear term, 2x plus 3. And some people are thinking, D. Why do you need the 2x? Like, is there anything special to do with the 2x? No, there's not. If you had like an x squared, there's something special to do with that, but we're not going to deal with that. So, I don't like the AP problems don't get like super complicated because they take so long to do. In your college classes, you'll probably deal with them, but right now, no. So, yeah, that's what we're going to do, and we're going to figure out. Same way as last time, we're going to get a common denominator, but instead of showing you and multiplying both sides by that common denominator, I'm just going to get rid of the fractions. So hopefully you remember from the last video that the fractions went away, and we just had the numerators. That's what I'm going to do on this one. So to get a common denominator here, well, I'm missing, and, well, actually, I guess I'll show it since I'm making the video. So here, I think I might need even more space than that. The common denominator would be, I guess, all of this stuff, right? So what is this missing? This is missing an x minus 3 and also a 2x plus 3. And so I have to do that in the top. And then I will get a common denominator for the b term. And, okay, what is that missing? And I can just compare it to this. It's missing a 2x plus 3. And I'll do that in the top as well, 2x plus 3. And lastly, this one's missing an x minus 3 squared. It's missing two of them. So x minus 3 squared. So now I have common denominators. I can multiply everything by that common denominator and get rid of the denominators. So I would just, and I'm not even going to FOIL this out. I'm just going to leave 4x squared minus 21x. And in fact, I'm just going to write the numerators. I'll pause the video. So I'm writing the numerators with the equal sign. Don't forget that. So there we have it, all the numerators. And now my goal is to find out what A, B, and C are. And I can choose I can choose any x values that I want, some convenient ones. And then later on, some not so convenient ones, but like they'll still help me out. So, first, what is a convenient x value to choose? Well, if I want to solve for, well, this is what I think. I'm always trying to get rid of terms. So if I want to get rid of this term, I can choose x to be 3, right? If x was 3,